Hello, welcome to class Calculus 1. Can you hear me and can you see me?
Yeah, we can hear you, but we cannot see you.
Understood. Okay, so I am joined on two accounts. They both have name Donovan. Ah, that's me. Ah, okay.
I can see you. Yeah.
Great. Thank you very much. Okay, so let me see how many students we have in the class. So I understand we have around 50 in the room. And I see we have 70 or more on Zoom, but the number is going up. So I think before I start, let's wait and see if the number goes up further. I know many more students are registered and also many more in WeShare group.
Okay, during the class, if you have questions, you can raise your hand, and then I will hand you the microphone, so you can talk to the professor.
Okay, so the number in the APP keeps going up, but I will begin first with organizational things, and we'll ask for your questions about the course. So my name is Will Donovan. I am professor here at Tsinghua, and we study calculus this semester. So let me share my screen and show some notes. Okay, great. So I think you can see that introduction to what we will study. So, of course, this semester is special because the virus situation, arrangements are very different to normal. Some of you are in the classroom, some of you are in very different parts of the world in different time zones. So we are all learning this new situation. This is the first time I taught a class like this. It will take some time to settle. So please be patient while things settle, and follow the arrangements I'll be explaining next. At first, I wanted to say something about why calculus is important. To go back to basics. So calculus was discovered around the year 1700 by Newton and Leibniz. And really, without calculus, we would not have science in the way we understand it today. So all of science and all of the technology we enjoy is based on our understanding of calculus. So just for some illustration, so before calculus, these were some of our most advanced technologies. So on the left, silk making in what is now the United States. And on the right, a windmill to use the power of the wind to make flour from grain. So we had ways of using power to make machines, but it's only through calculus that we've understood enough physics to go further. So by comparison now, just some favorite examples of mine, how we now have these rockets made by SpaceX, which can land independently and precisely. And the calculations, not just of where they fly and how they fly, but all the materials that they're made of, the processes that are used to make them, everything is built up step by step from calculus. And on the right, our tallest skyscraper. So the design and again the construction is based on calculus. So it's really not possible to understand the physical world without it. And not just the physical world, but also biology, medicine, and so many other things. I know you are studying a big variety of subjects, so you all have your different favorite things that this course can be used for. Okay, so let me start now with some organization. Okay, so I think as I do this, my video will freeze, but I hope you can still hear me. So about the organization of the class. So my name is Will Donovan. I'm professor here at Tsinghua, and my research is in geometry. Okay, first thing I'm going to do is write a bit smaller. Now, yes. So, about that. Yeah. Okay. So the first thing I want to explain is how we will have some class interaction. So that's still a bit big. So usually would ask questions to you and get some answer back. Maybe I'd ask you to raise your hand or to vote for an answer. But instead, let's try use WeChat for you to send answers. Okay. So I think many of you already joined a WeChat group for the class. It's called Calculus A1. So I'd like you to also join another WeChat group for class interactions now. Okay. So I'm going to show the information of those WeChat groups on this screen. And I'm also going to post in WeChat. Okay, so first thing, everyone check they have joined this WeChat group I'm showing now. And second, please join this group for classroom interaction, I'm going to call it. So the name of the group is Quiz. So this is not for questions. It's for classroom interaction. So I see many of you have joined. In fact, 140. Great. So I'll keep that on the screen for a moment more. So to test this quiz group, I'm going to ask you if you are comfortable with this. It's not a problem if you are not, to message which country you are in now. And I'm going to start. I am now in UK. Oh, that's great. So I see many answers coming back. Maybe a quarter of the answers are China, but the other answers come from all over the world. So again, welcome. And I hope you feel involved in this class, even though you are far away. Okay. So that's working. So next thing, I want to show the class textbook. So the name of the textbook is Thomas Calculus. Some details are here. Before the class, I uploaded the syllabus on WebLearn. and that also has the details of this textbook. So for most of the course, we will follow this textbook quite closely. So textbook is Thomas Calculus. And in the syllabus, you'll see 13th edition. And I think in Tsinghua, 13th edition is being sold. But I have 11th edition. And I guess other people will also have different editions. So I'm going to ask a question to you. You can reply in WeChat. So question, if you have, let me say this right. So have textbook, which edition? So answer, e.g., no, that's fine, or yes, 11th, or yes, 13th, or whatever you have. I see. So I see some people have textbook, and most people who have textbook have 11th, but some have 13th. Okay. So I think 11 and 13 are probably quite similar in their contents, but maybe page numbers are different. So don't worry. Let me write. So no problem. About different editions. Will send photos for homework. Etc. So instead of sending a page number from the book, I will send a photo, and then I think it's okay. Doesn't matter which edition you use. Okay. So that's about the textbook. And let me say about syllabus. This is available from Tsinghua Web Learning So I hope most of you will have found that site. I will just call it so note also used for notices, homework, etc. Okay. Going to continue to get smaller as I get used to the size of this page. So next thing, office hours. So this is a time to speak directly with me. It will be on this same app. And we'll advertise times later on. Okay, another note. On the use of English. So I know some of you are English, some of you, your first language is something else. But English is our common language in this class. Please use it whenever possible. That's questions and writing. So this is part of your training. Okay. So a bit about homework. There'll be more details later. So homework set once a week. Is 20% of your grade. And calculus needs practice. So most of the homework will not be hard. Note, if you follow class, so please no copying of any kind. So questions will be from, so I guess you are smart enough to find answers to that online. However, because 80% of the class is exam, this is not a good idea. You should take the chance to practice. And if you have problems with the questions, then please speak to the TAs and speak to me. Okay. So I think that finishes everything I wanted to say about practical things. And we still have some time in the class left. So over to you. Any questions? Okay, I see one question. So the question is how to ask questions on Jumu or on WeChat. So let me write that out. Question. In class, questions on Jumu or WeChat. So let's try Jumu. Let's see how that works. So the person who asked question during class time, how should ask questions? So I'm sorry if I read your name wrong, but maybe it's Gaomi Ke. Could you turn on your microphone and say hello as a test?
Yes, hello, sir. Can you hear me?
Absolutely.
Okay, great.
I can hear you. Okay, so, and now turn your microphone off, please. So that seemed to work. Great. So the answer to that question is Jumu in class, and I want to add WeChat outside class. Okay, I'm checking the right. Okay, Benjamin Lee, could you do the same test? Just turn on your microphone, say hello, ask question.
Hello. So my question was, how are the tests or quizzes carried out? Or how do they work?
Okay, so I'm going to change that a bit to tests or exams. I'll say why in a moment. How are tests and exams done? So answer. So I plan a midterm exam and final exam. Details to be decided. Yeah, so obvious question is, when you sit exam, how will you send back your answers, especially if you are not in China, in the university. So we will find a way, but not decided yet. Okay, and I'm going to add another question. So how are quizzes done? So the answer here is in class using WeChat. And they do not affect grade. Just for interaction. Okay, whereas the midterm exam and the final exam, these of course are part of your grade. Whereas when I say quizzes, so this quiz WeChat group, just for interaction, check, understanding, or not. So don't worry about the answers to those. Just say what's in your mind. We'll test later once we've learned something. Okay. I see. So ask questions just by voice. So what's the percentage of exams? That's not decided yet, but I will let you know, of course. So where our recording is going to be uploaded online, I also don't know yet, but we will be working on that. And a related question, is it okay to see recordings due to time zone differences? So again, I have to confirm the recording system first. Okay, so I'll remember those questions and give answers as we go. So I understand that people are on different time zones where it's the middle of the night, and so there is an issue there. Okay, and yeah, so I think I see some more questions which are great. I'm sorry I can't answer them all, but I want to talk, the class period is about to end actually. We will have 5-minute break and then do some math. So let me answer the last question. So this is from, I can't read the name, but someone on the waiting list. So question, I'm on waiting list. What will happen? So answer, department is reviewing okay, it's time to stop. I'll just finish writing this. So there will be more information, but I don't have more information yet. So I know that there are people on the waiting list who want to take this class, people for whom it is listed as compulsory class in their course, and the department is reviewing the maximum number of students that can attend this class. Okay, so let me stop there and let's have a 5-minute break and then we'll start doing some math. Thank you very much. Okay, so I just wanted to say, in class, let's try asking questions on Jumu and typing them in. Let's see how that goes. Okay. So the first section of this course, you'll see on the syllabus, is about functions. So I think many of you will have studied these. And so some of this material will not be new. In that case, I recommend find the book and read further. Okay, so I'm just getting my notes on the screen. Some difficulty there. Okay, now it's working. Okay, a section. But first, again, the size is too big. Natural numbers. 1, 2, 3. I'll write those as n. Integers, I'll write as z like this. Positive and negative numbers and 0. I'll sometimes write q for rational numbers. Those are p over q, where p and q are integers and q is not 0. But we'll mostly be studying in this course the real numbers. So for instance, square root of 2 or pi, and there are many others. And note that the natural numbers are a subset of z, are a subset of q, are a subset of r. So these 4 systems of numbers live inside each other like that. So first thing, let's talk about intervals. in the real numbers and make some notation for them, because we'll be using this notation a lot. So starting with a definition. This is just how I write definition. So DEF up N, just a way to write definition. Should show it to you so it's not too confusing. So some subset U of R is an interval if two conditions U contains two different numbers and two for B and C elements of R where A, B, and C are in order like this, then if A and C are both in U, then B is in U. So this symbol means implies. Or if then. So if A and C are in U, then B is in U. So this is a complicated way to say something I think you've already seen. But it's important to make this definition carefully. So remark, important. To make this definition carefully. We will see why. So here's some examples. I can take U to be the set of X. I'm not writing it, but X is a real number in R. All X that satisfy this inequality. Okay, so let me write means set of X such that, in this case, 0 is less than X, less than 1. Draw that, So this is the real number line. These are 0 and 1. And I draw the interval like that. So let me give another example. Oh, I should say when I write e.g., I mean example. Yes. Here's another example. U is the set of X such that this inequality holds. And I can as well. Like this. But notice how I'm using circles, not open circles at the two ends. Okay. So in this case, we say the interval is open. In this case, we say it is closed. And let's give one more example. So now the inequality, you can see, I'm not drawn very well, but these should be the same length. Something like that. So note now these are different. And I draw this by having one open circle and one closed circle. And we call this a half open interval. So you can check, do we fit? Yes. So each of these sets U satisfies the definition of interval. So I'm going to come back onto the video. So in each of these sets, certainly there are two different numbers in the sets. There is an infinite number of numbers in each of these sets U. And if I take two of the real numbers in the set, then any number between those two, so if those two are A and C, any number B between those two is also in U. Okay, so I'm going to check back to see if there are any questions in the chat. Okay, so there's no new questions. So unfortunately, because of the way my computer is set up, when I'm viewing my notes, I can't at the same time view the chat. And so we'll have to think about that. But I'll check back every now and again. If you have questions, please put them in the Google chat. So now let's establish some notation for these types of intervals. So I'll just give the examples. That the first one is written with round brackets, and the second one is written with square brackets, and the third one is written with a mix. Okay, so now not everything is an interval. So I'm going to write some non-examples. So using this same notation, so 0, 1, union, 3, 4 is not an interval. So why? Well, remember from the definition, if we have A, B, C in order, and A and C are both in U, then B should be in U. But if I take 1, 2, 3 in order, then 1 and 3 are in U, but 2 is not in U. So it fails the second part of the test. So another non-example let's take just the number 0. So this is a set with one element. I'm just going to write it clearly that this is, again, not an interval. So Y does not contain two different numbers. Oh, I spelled different wrong. Okay. Okay, so while we're around, let's check back. Yes, part 1 of the definition was that U must contain two different. Okay. Okay. So another topic will be revision for some of you. So this is written like this with 2 bars. And it's defined in this way. That for positive x, I just take x. And for negative x, I take minus x. So this is always positive. And let's make a note that this notation, square root of y, means the positive square root of some y, positive or 0. And so, another way to write this absolute value function is the square root of x squared. So if x is positive, squaring it and then square rooting does nothing. If x is negative, then it changes the sign. Okay, so note this has a relation with intervals. So for instance, for a positive, new page. Yeah, again, I'm going to write a little bit smaller. Because I think it's clearer if I can keep more on the page. Try this. So if the absolute value of x is less than a, that's true if and only if x satisfies this inequality. And let me write that as an interval. So in the notation we made at the start, x is in the interval, so open interval. Yes. And now, if I do the other thing, ask for x greater than a, then the result is that either x is greater than a or x is less than minus a. And that is the same as x being in Okay. So we didn't introduce, but we can write that in interval notation as well. Okay, so an example. Solve this inequality here. So how are we going to do this? We just use the note above and then we do some algebra. So, oh, I should say, in case it's not clear, before we had an arrow going in one direction, means if, then. This is arrows in both directions. And we say this as if and only if. So what does that mean? If the absolute value of x is less than a, then x is less than a and greater than minus a. But also the other way around. If x is less than a and greater than minus a, then this is true. So it's if and only if. Okay, so let's solve this example now. So from the note, this is true if and only if what's in the absolute value, 5 minus 2 over x, is between these two numbers. Now, if I have an inequality, I can subtract from both sides. What do I get? Minus 6. And minus 4, but it's simplified because now I just have minus 2 over x in the middle. And I can divide by minus 2. And I get 3 divide by minus So I have to flip the signs. I should say flip direction. Of the inequalities like this. And to get just x in the middle, I do 1 over 1 divided by, and again the signs flip. Okay. So this line is apply 1 over something. And note, of course, 1 over x is just x. Okay, so another similar example. Let's solve 2x minus 3, absolute value is greater than or equal to. So by the note, if the absolute value is greater than or equal to 1, then either 2x minus 3 is less than minus 1, or 2x minus 3 is greater than 1. And I can add to both sides of this. And I can add to both sides of this. Oh, I made a mistake. Can you see? I missed out these. Okay. And then I can divide by a positive now. So no flip in direction. Okay. So let me just draw this on the number line. So this is value 1. This is value 2. So note, this is union of two intervals. Let's write them A and B. But of course, these intervals keep on going. So we can see they are intervals because, for instance, B, of course, it has two elements. It has infinite number of elements. And if I take any two, there must be one between them. And the same with A. So we call these infinite intervals. And so the meaning is infinite on the real number line. So we write minus infinity to A. So it's the same notation, except in one of the places we have this symbol for infinity with a minus. And in the same way, we can write with a round bracket and get this. So we say this is a closed interval. This is an open interval. And so the example above, we can write, let's remember, so x less than or equal to 1 or x less than or, sorry, x greater than or equal to 2 is true if and only if x is in this infinite interval union this infinite interval. So note, so I define A like this. So remark, of course, minus infinity and plus infinity are not members of R, we just use them to make this notation. Okay, so I'm coming back to the app and I see maybe some questions. Yeah, so 2 good questions. So question, so can an interval have any skipped numbers? So let me copy this example. So the answer is no, not allowed by part, how did I write it? 2 of definition. So in this example, one and 2 are in my interval. Sorry, should be careful here. So let's define U is this set. So this is not an interval. Why? Because 1 is less than 1.5 is less than 2, and 1 and 2 are in U, but 1.5 is not in U. So you can see that 1.5 has been skipped. Yes. So question, to solve an inequality is sign needed. So I'll answer that after the break. Thank you. And if you have any more questions, ask them during the break and I will see them when we start again.
Hello, sir. Can you hear me?
Hi, yes.
So I've seen a few of you classmates in the WeChat group talking about whether or not you're gonna provide the lecture notes. Are you going to provide the lecture notes after class?
Yes. So
Okay.
I didn't make a plan yet, but I think I can just upload PDF to Learn.
Okay. Okay.
So
Thanks.
I will try that today. If a better system is better, like WeChat, then we can try that. But yeah, there will be some way. So I appreciate that you can only see one blackboard or one whiteboard. It would be good if you could see more. So it's good if you can look at the notes later and see everything together.
Okay.
Thank you.
Okay. Thank you, sir.
Hello? He froze.
Hello. back again. So third period of 3. So I'm checking questions. Okay, so a few more questions. So I'm going to go one by one. Let me make a note on the next page, actually, so I don't forget the questions. So question, will you upload notes? The answer is yes, I'll give details. And question, explain etc. Good question. Okay, and question, Thursday lecture plan. I'll explain that. Okay. So back to this question, to solve an inequality, is the sign I wrote needed? Okay, so there are two issues here. Let me think of a good example. Yes, okay. So there are two parts to the answer. So answer 1. We must show some idea of if and only if. So let me explain the reason why. So, example, solve absolute value of x is less than 1. So solution so this is a wrong solution if I write down that the inequality implies x is less than 1. Okay, so this is true if the absolute value of x is less than 1, then x must be less than 1. But it's not full solution. Let me show you why. Solution. So if x is less than 1, like we said, then minus 1 is less than x is less than 1. But also the other way. If minus 1 is less than x is less than 1, then the absolute value of x is less than 1. So this means that any x which satisfies this inequality on the left must satisfy this, and also all these x's satisfy the inequality. Okay, so this is the right solution because so full solution. Because we found all solutions. Okay, so the second part of the answer is we can use different ways to show if and only if. Okay, so let me give an example by copying from above. Maybe this one is good. Okay, so I showed you before how to write it with if and only if sign. So IFF, this is abbreviation for if and only if, IFF. So good way to write the solution. And here's another example. Here's another example. Take the same thing. I could say the following are equivalent. So I sometimes write for this TFAE. The following are equivalent. So some other questions. Oh yeah, let me answer this math one first. Yeah, so I hope this was the question. Just what do I mean by this sign here? So this shows how shortened word ends. So example, DEF line M means definition, THM would mean theorem. And like that. It's just the way I write, but I think it helps because, as you know, especially those people who studied English as a second language, the end of the word is important. So that's an abbreviation that lets you show the end of the word, even if you don't show the whole word. Okay. So will I upload notes? So yes, we'll make PDF of these notes and upload to Learn. So this is the website for the course that I mentioned earlier. So question about Thursday lecture plan, what time is it? So the answer to that is it starts at the same time as the Monday lecture. So start time as Monday. Length 2 sessions. So i.e. it's time Thursday 7:20 to 8:55. And it's every week. Okay. Any more questions before we continue? So I saw there were some questions also on WeChat. Okay, so I see some more in the chat. So I just want to request Mhm. Please use Jumu chat only for asking questions. So let's use WeChat for discussion. And the reason is that if there is a long chat on Jumu, I can't read it and see which questions. Okay. Okay, so let's continue. Okay, so I want to talk a bit about drawing graphs. So remark, can do by some app, but important to learn to draw yourself. For instance, in an exam, this helps understanding. Okay, so some examples. If I look at the graph of y is the absolute value of x, so let's take axes x and y like this. Now the graph looks like this. If x is positive, then y equals x. But if x is negative, then y equals minus x. That's what this graph shows. And simple one to practice. Y equals x squared. Same axes like this. Then the graph looks something like this. So we can make this, we can make this by plotting the value of y for 1, 2, and so on. We get something like this. For y equals x squared. Okay, and looking at this graph, we have some feeling for what the slope of the graph is. So for this, just imagine hill, where the height is y equals x squared for x greater than or equal to 0. Okay, so the graph again is like this. And now let's imagine we're cycling up that slope. Okay. So of course, this is not in Beijing. Beijing doesn't really have hills. So as we cycle up, we can see that in some sense the slope increases. So the question is, how much does it increase? So let me give some definition. The slope of line L. So this doesn't answer a question like the one I drew, but the slope of a line. And I actually want to take a non-vertical line, as you can see. Okay. Okay. So say the line is this one. And just pick 2 points on it. With coordinates x1, y1 and x2, y2. Then is M. And this is the difference in y over the difference in x. Okay. So I'm going to write down, this means difference, or I wrote difference wrong again. Difference or change in a quantity. So it's Greek letter delta. And in this case, divided by the difference in x. So for example, y equals x has slope m equals 1. So rem I don't remember whether I said that this means remark. So we can use calculus to calculate slope for curves. And we can do that lots of other applications are possible. Okay, so before we do that, it's going to take us a few weeks to get to that, but let's keep on with background material. So this, I think we know. But let's review the equation of a line. So if the point x1, y1 is in L, as above, have equation like this. And this is because if one of my points is x1, y1, and the other point above as xy in L. And then we use the slope equation. Okay, so that's the equation of the line. All the points x, y on the line satisfy this equation. And there is a special case that if the point I choose instead of x1, y1 with any x and y on the line, I pick something where the first coordinate is 0, so drawing a picture, so say our line is this, and 0, comma b is in the line, then that means the line intersects the y-axis at b, or i.e. that is y-intercept is equal now to b. And then what we get, this gives that L, just by the above formula, is y is mx plus b. Okay. So coming back to Zoom and restarting my video, checking for questions. Okay, so there's some questions about the book and the app we are using, and I will answer those later. So now I want to test the quiz system. Now, so as a test of this, I made a few questions to review the material at the beginning of the lecture. So I'm now going to switch over to those questions. Here we are. Okay, and I can already see some problem because maybe you just saw some of the answers. Okay, so this system will improve, but let's just try it together for the first time, and we will repeat each class. So again, this is just a quiz, so your answers don't matter. It's just to check what you understand and what you don't understand. So for this question, please answer now. Now in quiz WeChat group. Great, okay, so answers are coming in. So many people answer B, and the answer is indeed B. Okay. So yeah, so let me explain why. So this means bigger. The largest integer z which is okay, so 0 is a solution because the largest integer less than or equal to 0 is 0 itself, and that's minus 0. And negative numbers are also, or negative whole numbers are also solutions, because in that case, again, the largest integer less than or equal to that number is minus n, value of minus n. That's just n. Okay. Also, thank you for your involvement. So, and okay, so actually, maybe just going to check. Oh yeah, so I need to go into this. Okay, so these are some exercises from the book. This is exercise 1.1. They're about solving inequalities. And so the next question is just one of the questions from this set. So I'll bring it up. But I first want to say, so please answer without looking at answers. Of others. So soon I will show the question, and please think of your own answer and write it in. Don't look at the answers of others. Okay, so there are two inequalities here. I've drawn out the solutions on the number line. So there are 4 possible solutions. Which one is the right one? Okay. So there's agreement again. Good. This means the questions need to get harder, perhaps. We can do that. So our answer is B. And let's see why. So in B, we have this open interval -2 less than x. So this inequality. And for this one, the solution is -2. Okay, great. So one more question. Coming up. I'm going to write in question 3 in the group, and question 3 is this. So we have u equals 0, just single element set, just 0. And we have v, all the real numbers that are not 0. Okay. And the answer's coming back. V And that's correct. This first one is not an interval, just one element. And this second one is not an interval because, well, 0 is skipped. So -1, for instance, is less than 0, is less than 1. And 1 and -1 are in V, but 0 is not in V. Thanks for being involved in that. Continue to work on that sort of quiz interaction. Okay, so just 5 minutes left. Let me continue on. So we talked about lines. Let's talk for 5 minutes about parabolas. These are an important example for us. Okay, so for example, the parabola given by ax squared plus bx plus c. So let's do an example. X squared minus x. So the graph of this looks something like this. Oh, I'm going to draw it here. And then move it into place. So if y equals 0, then x is 1 or 0. And we'll talk the beginning of next time how to make the rest of that graph. But that's an example. So remark, there exist other parabolas not defined in this way. E.g. x equals y squared. So there exist. That's what this symbol means. There exist, or there exist other parabolas. So I could, then my parabola would be, well, let's draw it. So then my parabola would be this. Okay, so just 1 minute. Nice fact to end on. Parabolas defined geometrically how they reflect light. here, and the light shines. Oh, one moment, that's not quite in the right position. Here, and the light shines from that. If I get it in the right place, and the light reflects to parallel beams. So light source, these rays in parallel. So that's a beautiful thing about parabola. We'll talk more about how to draw them next time. Thank you very much. And I'll stay on for any questions.
Hello?
Hello.
Yeah, so are we planning on like finishing the textbook in the first semester, or is that like a full year thing?
No, it's more like a full year to not finish the textbook, but do most of the textbook. So after the class, you can look at the syllabus on Learn, and you'll see that the first sections of the syllabus are chapters of the textbook.
Oh, okay.
So I think chapters 1 to 9 are studied in this class.
Right.
And yeah, then maybe there are almost 20 chapters. So yeah, the textbook is more like a year.
All right.
And so there are 9 chapters that we will study most topics from, not all. And after that, there's some extra material on differential equations, which is not from the same textbook. Okay, thank you.
Thank you.